Hi dear students, a warm good morning to all of you, and today we are going to continue with electron microscopy, especially the sample preparation which has been needed for electron microscopy. Now, if you go to look onto the sample preparation, the specimen preparation for transmission electron microscope is almost analogous to the procedures used for the light microscopy. But the only difference that which we need here in transmission electron microscope is that the specimens which are taken here should be cut to a very thin section, and only then the electrons will pierce through it and come through the other sides. So you have an extra section or an extra portion of processes which have been needed for the cutting of the microorganism under in study into very thin slices. And once they have been thinly sliced, the specimens are further chemically fixed, and then they are being stained with the electron dense materials. So how do we make ultra thin sections? Usually extremely thin slices of about 20 to 100 nanometer of a specimen is being viewed because the electron beams are easily absorbed and scattered by the solid matter. And so in order to slice the specimen into a thin slice, the specimen is in fact embedded in a supportive matrix. And sometimes it will be plastic, it is made up of plastic also. So you take the specimen and you embed it in a supporting matrix. Sometimes it will be epoxy plastic and all that. And along with the supportive matrix itself, it is being fixed with chemicals called like glutaraldehyde or osmium tetroxide. So the cell structure is being stabilized. Later on, so unlike the light microscopy where you heat fix it onto the glass slide, here you are using chemical fixation of the microorganism onto the which has been already been placed on the supportive matrix. Further on, the specimen is dehydrated with organic solvents, uh, and complete dehydration is being needed because most of the plastics which are being used for embedding, they are not water soluble. So we need to completely dehydrate it. And next, the specimen is soaked in unpolymerized liquid epoxy plastic until it becomes completely permeated. And then the plastic is hardened to form the solid block. And thin sections are cut from the block with a glass or a diamond knife using a device called an ultra microton. So you have your specimen, you have fixed it using glutaraldehyde and osmium tetroxide, and then dehydrated it, and then you are putting it in unpolymerized plastic, lipid epoxy plastic, so that a solid supportive matrix has been formed. And once it has been hardened onto a block, you take that block and cut it with a glass or a diamond knife using a device called the ultra microton. Now, once the ultra thin sections are being obtained, you need to stain it. And if you go to look onto biological samples, they have carbon, hydrogen, nitrogen, and oxygen. And electron scattering ability is fairly constant throughout an unstained cell or a virus. So what you do is, you try to make the specimen to be found to be more electron opaque. So in order to get the more electron opaque nature of the specimens, what you do, the specimens are soaked in a solution of heavy metals such as a lead citrate and uranyl acetate. So once these substances like lead citrate as well as uranyl acetate, which are being used as stain, are being added or the specimen is immersed in it, these ions will bind to the structures in the specimen and make them more electron opaque. So they will get a better contrast in the material. And you can see that the heavy osmium atoms from osmium tetroxide, which has been used as a fixative, that will also stain the specimens and increase their contrast. So the stained thin sections are then mounted. So once you have stained it, then again you mount it onto a thin copper grid, and then it is being viewed. So if you go to look, this procedure is a type of staining which is being used. So the procedure which we use is normally is a negative staining technique for staining for the staining of when you use transmission electron microscope. So what do you do is the specimen is spread out in a thin film with either uranyl acetate or phosphotungstic acid, and then what happens? The heavy metal atoms do not penetrate the specimen but render the background dark, whereas the specimen appears to be bright in photography. So such a negative staining technique can also be used here. And the negative staining is an excellent way to study the structure of the virus particles, bacterial gas vacuoles, and as well as other similar molecules. So this is an example in which a bacteriophage is being viewed by what? By negative staining. So what would happen? The background, as I told you earlier, the uranyl acetate will be found, will make it to be more electron opaque. And the background will be considered to be what? It does not have much of carbon, hydrogen, particles and all, carbon, hydrogen and oxygen as we told. So those particles, the background will be found to be negatively stained. It will be dark in color, and the specimen which is being viewed under the electron microscope, it will be more electron opaque, and it will more electrons will be passed through it, and it will be appear to be brighter. So against a dark background, the organism or the specimen which is being viewed under the transmission electron microscope will be viewed as a brighter one. And sometimes the negative staining can also be combined with immunostaining techniques, where a primary antibody and a gold labeled secondary antibody can be used to reveal the morphology of biological specimens, as well as for testing the presence of particular antigen on the specimen surface. But if you're not going to that level of study, you can just learn about the negative staining technique, which is being used for the electron microscopy. In addition to the electron negative staining technique, now we have other techniques called the shadowing as well as the freeze etching technique, which is also being used for the TEM. Now let's see what are these. What is shadowing? In shadowing, the specimen is coated with a thin film of platinum or heavy metal by evaporation at an angle of about 45 degrees centigrade from horizontal, so that the metal strikes the microorganism only on one particular side. And in one commonly used imaging method, the area coated with the metal appears dark in the photograph, whereas the uncoated side and the shadow region is created by the object they are considered to be as light. So here, since only one side of this heavy specimen is being found to be what? Coated with the heavy metal, what happens? That will be appear to be as dark in the photographs. So this technique is particularly used in the studying of virus particle morphology, bacterial and archaeal flagella, as well as DNA. So that's about shadowing. Now, in some cases, you can also use a freeze etching technique. What is a freeze etching technique? That is, when you want to find out the structures or the shape of the organelles within the cell, we use a technique called the freeze etching procedure. So what is a freeze etching? In freeze etching, what does it means? You take the cells and it is rapidly frozen in liquid nitrogen. Liquid nitrogen is a liquid thing, and once liquid nitrogen is very much cold. So when you put something onto, or you put liquid nitrogen onto something, it becomes very much cold and it becomes very brittle, and it can be broken along the line of great weakness. So what do? You take your specimen and you freeze it with liquid nitrogen, and then the exposed surface are then shadowed and coated with a layer of platinum and carbon to form a replica of the surface. And after the specimen has been removed chemically, this replica is studied in the TEM, providing a detailed view of the intracellular structure. And the advantage is that it minimizes the dangers of artifacts because the cell was frozen quickly rather than being subjected to chemical fixation, dehydration, and embedding in plastic. So in the normal specimen preparation for the TEM, what you do, you have a fixation, dehydration, and then you put it in the plastic, and then you take a ultra thin using an ultra microtome, you take thin sections and then you stain it. Here, instead of that, what you do is you will freeze it, and then you will go for freezing using liquid nitrogen, and then after that you go for the staining procedure using platinum and carbon and all. Now, these are the methods which we use for the sample preparation of TEM. The sample preparation of SEM, or the scanning electron microscope, is being found to be relatively easily because we do not have to take thin sections, because only the surface morphology of the organism is being analyzed by a SEM. So you can even take air dried materials, uh, and sometimes they can be directly viewed by a SEM. But microorganisms must first be fixed, dehydrated, and dried to preserve the surface structure and to prevent the collapse of the cells when they are being exposed to the SEM's high vacuum. And before viewing, the dried samples are mounted and coated with a thin layer of a metal to prevent the buildup of electrical charge on the surface and to get a better image. So in the SEM, we do not take a very thin section. You need not take a section like that, but you should make sure that it is fixed, dehydrated, and dried before you are coating it with a stain. So I guess you are clear with the sample preparation which is being needed for the electron microscopy. With this, we come to an end of the session. Thank you.